turn it over to you, Ashek.
Okay. Thank you for having us. Really glad to participate and share some of the things that we are learning on the journey to AI. So we are from IBM, part of the consulting business. This is where we work with our clients across different type of technologies. We really call it a hybrid cloud and AI journey. That means we may work with different type of cloud technologies, on-prem technologies, kind of bringing them together to build the AI solutions. How do we apply data science and put that into applications that a consumer can actually use? This is basically where we focus on. And in terms of industry, we focus on Canadian industries. Our team, we focus on Canada. And within Canada, we work with governments, airlines, retailers, financial services, banking, insurance, payment providers, industrial clients like oil and gas, mining, basically all of those things where Canada has a heavy footprint of business leadership. We work with those business and see how we can bring data and AI and automations to further fuel their business and lead them through digital transformation and bring them value. So the focus is not just science experiments, but putting AI into the practice and how we can bring values, real business values, real value to the Canadian market. So if I kind of talk about the agenda today, I'll talk about a few case studies on what we are doing, and then Nizar will speak about our AI strategy, and Amaladi will touch on the evolution of the AI technology side. Now, a case study I'm really proud to talk about always is the work we're doing with a major Canadian railway. So they have trains that basically, when they pass in front of your crossing, it takes 15 minutes. They carry the supply chain for Canada, not just Canada, like they're a tier 1 North American transport company. And the use case was, how do I automate the safety inspection of the rail? If you think about it, like a train, when you do inspection, not only you're checking like the connections, the joints, the wheels, the bearings, the braking system, there's a lot of things to check. And for an inspector to stop a train in a yard and to check that, right, all of those, it can take a lot of time, as well as there's a lot of safety risk around, going under a train and checking. So we wanted to automate that process. The solutions that we have is basically creating a portal with cameras that the train will go through before it enters the yard. And basically, as the train enters the portal, the cameras wakes up, take pictures. One train generates about 20,000 images. And then now we have to process those images and identify anomalies. Now, if I were to send all those 20,000 images over the network to, let's say, cloud, and build the data science algorithms that runs on the cloud, it would take a long time. So what we wanted to do is to do that within the next 10 minutes. So we already know before the train leaves the yard, if the train needs to be stopped and inspected, or we just let the train go. And to do that, we have to build the whole system on the edge. By edge, what we mean is running algorithms close to where the data is generated. In this case, just by the camera systems, we have infrastructure set up, and then we run the machine learning models for computer vision right there, orchestrate them. We have over 300 models running, 75 inspection use case, processing 10,000 plus images, all within 20 minutes to automate some of these inspections. So it's much safer way of doing it, cost-effective way of doing it, and time savings as well. As you understand, like missing some of these defects could have big impact. And for a sustainable future, this is quite an important piece. So that's one use case that we're really proud of, and we are working more with these type of clients. I just wanted to touch a little bit about, again, a lot of text. What I wanted to tell you is that from here is a lot of clients, this is an airlines, again, we're working with in Canada, that wanted to do AI and analytics and find that because the data is so disparate across different line of business, different systems, sometimes you can bring the full value of AI. And to bring the full value of AI, you need to have a consistent data approach, which is now giving rise over past couple of years. We see a bit of kind of slowdown on doing just proof of concepts around machine learning and more work around building a sustainable data platform, focusing on more robust cloud technologies that can integrate data across the line of business in a way where it's easier to do machine learning and more accurate, with more consistent data quality. And that's what we're doing with an airline, where we're taking all of their line of businesses data into a more of a data fabric that it cuts across different domains, but has this consistent architecture and a way to get the data for analytics. Could be advanced analytics or reporting, but we have a consistent architecture. And that doesn't mean all the data needs to be centralized in one place. It could still be in different places, but the architecture is consistent. And this is a new paradigm that's called data fabric or data mesh. And if you're interested in AI, I think it's also very important to understand data fabric and data mesh, because without those foundation in place, it's really hard to get the full value of AI, which is what large enterprises are focused on right now to build such data platforms. This is an example of Canada Post. Like if you call Canada Post these days, especially during COVID, long wait time. So what we're doing is building chatbot, virtual agents to transfer some of these calls into other areas that can be handled by a bot. And this has significant impact. 80% of the calls can be contained with our chats, 80% of the chats per days that were contained within the chatbots without actually handing it over to a human. And developing this chatbot, there's a lot of technologies out there right now. You don't have to quite go chat GPT, which is large language model, very open-ended questions, but you can actually build very specific Q&A that a chatbot needs to know for a particular enterprise using a lot of these chatbot tools like Watson Assistant from IBM or other cloud companies. You can train them without needing to know a lot of coding. It's very much kind of like building a process flow and creating a language model around question and answers. So this is quite a bit of successful projects. So I think these examples, you can kind of see different flavor. We're doing AI with sort of IoT type of data, computer visions, very much physical, digital conversion with AI. We are building data platform with some clients that will allow them to create more advanced analytics, forecasting, type of machine learnings. And then we are also applying AI for customer service, bringing some of these chatbot type of things. And that's kind of where we see kind of like the top priorities with our clients. It's really, how do I do more hybrid customer service, right? With COVID, a lot of people are now able to do digital customer service, but at the same time, there's a need to do things local. So how do I bridge that? There's a talent shortage. Of course, we know a lot of areas of service needs more talent, and AI can help automate some of that capabilities where human can focus on higher value activities. Sustainability is big on everybody's agenda. So data is the key to understand our footprint around climate risk and creating more sustainable future. Security is really big on everybody's agenda. Again, data and AI, as well as newer technologies like quantum, are going to be big on cybersecurity. And last but not least is supply chain, right? As we need, there's tremendous pressure on supply chain right now. And AI analytics can be a big agent to support that. So these are the areas where we are really focused on in Canadian market in these domains, not just general AI, but focusing on finance, supply chain, sustainability, customer service, talent transformation are the domains where we're creating capabilities around these functional areas, bringing machine learnings. That's basically how we focus around some of these. So those are the case studies I'm going to take you through today. And I'm going to hand it over to Nizar to talk a little bit about a model that we have created that we call basically the core competencies that you need to build an AI-driven enterprise. So Nizar, over to you.
Thanks, Ashek. So I really want to use this model to kind of set the stage to talk about the evolution of business strategy as it relates to AI over the past 6 years. And we have noticed a dramatic shift in the way companies are thinking of AI and using AI as a tool. But before we get there, just looking at these 6 competencies, which really mirror the competencies of a business, Your first is your vision and your strategy. And this is where organizations usually answer the question of how does data, how does AI fit into the goals I want to achieve and the sort of business that I want to build. Second, getting into data and technology. This is what most kind of look at when they look at AI. What is the architecture? What are the solutions? How is it managed? How is it governed? Then we get into tooling. So AI engineering and operations. So what tools are we going to leverage? What workbenches? What platforms? How do we deploy them? How do we maintain them? And now for the final three competencies, you start to move away from technology and more into the way the business operates. So the operating model is essentially, okay, we've built these applications, these AI products, if you will. How do they fit into our existing business processes? How do they fit into our day-to-day? Change management looks at how does it fit into the way that we work, and how does the organization sort of reshape around these new processes? And finally, people management. And I'll touch on this in a bit later, but this is the culture shift that comes with saying, okay, well, I'm going to trust this algorithm, or I'm trusting this product to make a decision and help me, or I'm going to trust this virtual agent to give me the right answer. So all of these together, enable an organization to become truly data-driven. But what that means and how they leverage AI within these competencies has kind of changed over the past, like I said, 6 years. And 6 years is a timeline that starts from about 2017, which is when, as you know, Canada kind of went on its national AI journey. We set out a strategy. We opened up investment, and that kind of trickled throughout the private enterprises. So if we go to the next slide. There we go. Oh, way too far. One back. Okay, there we go. So if we look at, at the start of this journey, the focus across enterprises was about doing AI. And what I mean by that is every CEO, every CFO, every CIO, and the new chief data officers knew that AI was going to be a differentiator, right? The funding was there. They were sold on the technology, and that sort of became part of a lot of the vision among companies. We started to hear the term data-driven, AI enabled, and the focus was really about setting up the capability, the belief that essentially we build it and they will come. So ensuring we have the right governance. This is where a lot of organizations went into building up, their data platforms, consolidating the information from across the organization and making it available to build advanced algorithms or business intelligence. This is where they were looking at what's the right tooling, what's the right platform across cloud platforms like Azure and AWS, and really a focus on building the capabilities, standing up the teams, getting algorithms developed. And in this phase, it was a lot of prototyping. But if you go to the next slide, where we are today is a very different environment. For one, thank you. For one, the market environment is very different. There's a call for very real ROI on all investments. And AI has been generally one of those more complex areas to quantify the benefit behind. But that's really what's being asked for today. It's no longer about doing AI. It's no longer about exploring. It's no longer about the capabilities that you have. What we're seeing more and more is the conversation is shifted towards how are you adopting ROI, AI, and how are you adopting it to better serve your customers, to create better employee experiences, to drive revenue up or cost down. And so the focus has shifted away from, okay, what are the technology capabilities? What are the tooling to how do we get this working, right? What's your vision for AI scaling across the org? What's your vision for embedding it in your business processes? How do you align? We talked about government here. We also talked about rail. How do you align the regulatory environment to what you want to achieve with these algorithms, these models, these new decision capabilities? And the even harder task, which Melody will touch on, ChatGPT and foundation models that made this a bit easier for all of us, but still a difficult task of change management and changing the culture for people to be able to accept these algorithms and what they'll be used for, but B, actually understand them. And it's not about the data scientists and the business analysts and the folks who are closest to the algorithms understanding them. It's about the end user. And just to kind of sum all this up, and transition to Omalade, who will kind of explain how the technology has evolved to come alongside this shift in business strategy. The focus and what we're seeing going forward is how can we as IBM and how can other consultancies enable clients to take what's out there, take the foundational technologies, whether that's something like ChatGPT or an ML ops platform or what have you, bring it into their business and solve the really hard problem of finding the right problem to throw it at. The problem with ROI that's quantifiable, with a set of users that are willing to accept it, with a regulatory environment that will allow you to deploy it. That's really the focus in today's world. Omalade, over to you.
Thank you so much, Nizar. Yeah, what I actually just want to do here, it's more to take us a little bit through the journey that got us here to the inflection point. And it's been like a history of evolution within the AI space. And we can look at it from different perspective, but I want to look at it more from the concept of data representation that is behind most of the AI that we're seeing today. The evolution of AI itself can easily be traced back to the development of expert systems of the 70s. And they were basically more, they were rule-based and they were designed to perform specific tasks, meaning you handcraft the symbolic representation based on if-then rules. And we saw that in the early medical diagnostic system, but they were limited because there's just a limit to the sort of representation you can have or the sort of knowledge you can encode for a machine to learn from. And that was why they actually didn't take off as much. And we saw early application also in the backend industry. But the introduction of the learning concept, in the 80s, was a major dramatic shift. It's a shift because now we're giving machine the opportunity to learn from data, right? Instead of specifying rule. But there were still some limitations that we saw because within that particular class, what you need to do is we take historical data. For example, you want to do, say, fraud prediction, you take historical data and you engineer your features. So in a way, those features are still crafted with representation, and you engineer them to be able to capture the sort of task that you're trying to design. So again, they were limited by the ability to add label, for example, from history, what you've seen, and instances of those specific scenarios that human can really label. So again, we use them today for most of the applications that we see. But again, the fact that you still need to discover the feature and represent the feature was still a major challenge. And then we started seeing in the early 2000, late around 1998, 2000 was when the deep learning piece started coming to play. And we saw a major revolution in that because now, even though we still have we don't have to handcraft features. It was at the point that you can ingest document and text, and machine is able to learn. Unlike in your standard machine learning that has specific format that is expecting, and you need to be able to like have, I mean, your data in that structure for you to learn. Now we're able to like ingest like, I mean, images, and the algorithms were able to like learn from like say pixels in pictures. And we started like thinking about things like object detection, voice recognition, visual recognition, like the visual inspection, I mean, case that I mean Ashek talked about. That was the evolution that allowed us to like, I mean, get there. Right now, we're seeing, if you can just go to the next one. Just click, yeah, thanks. Now, we're in the world where we have another inflection point. And that inflection point is what's really started with the concept of a foundation model. And at the heart of it is beyond just learning for a specific task. Because if I train model for conversational AI to like chat, that's what I've trained it on, because it's learned from probably the label that I have and the scenarios it's seeing, and I can only apply to that task. Now we're evolving to a point where you train a model for general task, and you can fine tune it for different set of tasks, which is like a powerful shift in paradigm within the AI space. But what actually made this possible is what made it possible. It's more the opportunity to like actually ingest like as much data as you have, not just what you can label. For example, like the GPT, which was more, the model that the chat GPT will like, fine-tune on, ingested all of the data you can find on the web. And try to like, learn from it. But I would say what actually made them, powerful. And one point I want to also, mention is this is starting, or it started from NLP, but in the implication goes beyond the natural, language processing space. It was just like the deep learning piece was popularized in the computer vision space. Their power, like we've seen, like generally deep learning has been applied to like text recognition, to text detection, like summarization, translation, and to object detection. And it's been used like in other areas, like even for fraud detection, because now you can have representation you can learn from. But what really makes them powerful is the concept of the self-supervision at scale. And I will talk a little bit around that. The compute that has continued to like, grown, and also the massive unlabeled data. So improvement in hardware, through GPU, but one cornerstone of why we can do self-supervision, at scale, is the concept of what we call like transformer architecture. And I'll talk about that because we've seen like a lot of evolution of deep learning architecture. And also that single concept of self-supervision, in which you can pre-train data, your model on data you have not labeled. It's allowed like language modeling tasks. For example, in one of the early foundation model, BERT, it was able to like predict, say, missing word in a sentence using the surrounding context, right? Ideal in an ordinary, pre that particular inflection point, what we need to do was like guide like our algorithm. But now you give a sentence and you remove some missing word, and based on the surrounding context, it's able to like fill in the gap using like dictionary and the knowledge of all the data is ingested. So it's potentially more useful than model that you train on labeled data. So that's what actually is the foundation of the shift. And I'm going to go to the next slide to talk about, just like in summary, just to unpack what I call the self-supervision at scale that enabled the transformation that we're seeing today in application like ChatGPT. Next slide, please. Thanks. So again, here, I'm not going to like get into the depth. It's more like an overview for us to like see the journey that some of the things we're hearing from foundation model didn't just like really start, today. I talk about the inflection point that we saw around like 2018, 2019, when the foundation model started to like, take shape. The progress in self-supervision is more we've had like a lot of different architecture, like the convolutional neural network allow us to like learn like deeply beyond just your standard neural network algorithm. But the new representation is what that is driving all of the innovation that we're seeing today is the concept of transformer architecture. And the whole idea about transformer architecture is it's more like you apply the architecture to unsupervised learning. Like all unsupervised learning, we really understand that like it's been around for a while, and it's well, all it means is without like human labeling, your data, you want to apply AI and ML algorithm to explore and exploit structure in your data. For example, we have in customer segmentation or document clustering. But over the last, decade, we've seen that, dramatic explosion in your deep learning with the newer architecture. So around 2018, when we have that transformer architecture, which again started from word of NLP, the architecture allows us to like use all of the data that we can have to like learn structure from. So you can see from the graph how the size of the NLP model has grown dramatically with the different transformer architecture applied, like the BERT, the GPT-1, GPT-2, Megatron, and GPT-3. Prior to this inflection point, most deep learning models were only able to scale to the extent of the data that you can label. If you cannot label it, then you can't really like train beyond that. So we're talking about model with few millions of parameters large. But as soon as that inflection point really happened, what we've seen is that exponential growth up to what we have in GPT-3. For example, the Megatron TNLG, which is one of the newest model, has about 530 billion parameters, which is really large. And that's why we see the shift that we're seeing today. I actually don't have a Chat GPT here because Chat GPT itself is just is a fine-tuned version of GPT-3. So you have like GPT-3 itself, which is what we call the generative pre-trained transformer as a large-scale language model that was developed by OpenAI, and you can adapt to various applications. And to just shed a little bit more light on that, I'll go to the next slide, just to like add some context as to how some of these architecture, like that powered GPT-3 and all those applications can enable us to like solve like different kind of problem beyond just the conventional AI that we see with ChatGPT. As if move to the next slide. Thank you. So I think this just summarizes the point I was making from you have like a lot of like content, like words and code online and everything ingested, and you have like self-supervised training that would produce you a foundation model like GPT-3 or like a BERT or like Megatron TLNG. If you just click on Ashek, please. Thanks. So you train like a foundation model. That's the whole concept. You ingest like this, large word, apply transformer architecture without label and as much data as you can give like the transformer architecture and let it like learn with the context around the data and produce a foundation model. And if we click on, so the foundation model now allows you to like do task specific fine tuning. And when we talk about task-specific fine-tuning, we're talking about things like translation model. Like I have a single train model. All I need to do is not to like train. It has much knowledge than anything. So for a specific task, I want to like do maybe within my organization based on like sample, like a label that I have, I can now train. I cannot just like fine-tune. So imagine like unlabeled data that say a GPT-3 was like trained on maybe 100 billion sentences is already pre-trained that you don't have access to. Now you can have as little as say like 1,000 examples within your own organization for specific tasks, and you can now train this pre-trained model, fine-tune it to like solve that problem. We just like click on again, please. Sorry, I think the yes. So this is just like, I mean, summarizing I think that's the major, I mean, takeaway about the power of foundation model. Like I said, like GPT-3 was trained on all of the data that you can find on the internet. Now, like ChatGPT itself was just a fine-tuned version of GPT-3 because it is specifically designed for conversational AI. And people get like excited about that, which is really great, but it just shows that the power actually like goes beyond that. And we're seeing like a whole lot of application. Like I said, it goes beyond the whole way like everyone like understand it now is only in the natural language, I mean, processing space, but no in digital interaction, in chemistry and material, programming languages, natural language, which we know, even in time series data and computer vision, this pre-trained, I mean, transformer model still help us solve problem on a large scale. Like you go to some, even though we say like ChatGPT is a conventional and question answering like I mean system. If you can ask like a question, like just describe a concept, say, give me data of this particular structure, and it will give you data. Say, give me inventory data with this particular structure, it will generate a sample for you. And if you give an instruction to say, oh, I want you to be able to like create a training algorithm or a model to use this data to do like maybe a forecasting or prediction or anything, it will give you a structure of the code, which you can take and run. And the power is more because of all the learnings that it's derived like over time from the knowledge encoded in those unstructured content. It's actually extremely like helpful. I know maybe a lot of us here have actually like play around with it. You can send a code snippet, meaning you write like your own code to implement whatever task, and you send it like ChatGPT, for example, and say, what's wrong with this code? Why won't it run? And it will tell you like some of the areas or things you need to like refactor. It's just based on the amount of knowledge that has been encoded there. Our research team, for example, they're working on symbolic representation for time series data. And the implication is just going to really blow up, because people are looking at time series data. For example, you swipe your credit card and you have transaction goes through. How do you detect fraud? Right, all those data like happening as transactions are happening, they come in a time series format. But that's not the only domain. Anywhere you have sensors, for example, maybe your manufacturing plant or production plant in oil and gas, or anywhere you have asset deploy, you have time series data. What our research team is actually doing right now is to have a symbolic representation of those events within those time series as they happen, and have a representation that translates them to a symbolic representation. With that symbolic representation, now you can apply any of this transformer architecture to learn better. And the initial result is actually it's been really inspiring. And that's just like let us know that everything we're seeing today as a transformation at the inflection point, it has huge application and implication like going forward beyond the world of NLP. So that's just the a short like history of the evolution of AI as to how we got here that I thought I'll share with you. Yeah, thanks again for having us.
Okay, I guess thank you very much. Great presentations, and we'll open it up for questions. And while we're asking those questions, or while we're waiting for those questions, so I love the presentation, all three of you. So I liked Ashek, your use cases, and then Nizar had looked at the 6 competencies, which are pretty interesting. And then Omaladi, you sort of ended up with sort of these inflection points, which I find is you encapsulated that nicely. Moving from the expert systems through to the machine learning, then deep learning, and now to these foundational models. So very, very interesting. So my question is this. You use the words context and generalizable, like that this newer model is generalizable, and it can, there's context around the data. And everything that I had read, now I am a novice, I am not a data scientist nor a computer scientist, but that to me is quite a step along the move from narrow AI to more general AI. Everything that, they always say, well, we're not a general AI yet because the computer or the algorithm can't generalize and can't put it in context. But it sounded to me like you were saying that this is that step that allows it to generalize and put things in context.
And that is right. And like I said, because we don't have the power to like learn from things we don't really like label, but having like an architecture that allows us to like take, like I said, I give an example of how like the initial like BERT transformer model was like implemented. It was given like, it would just be given like a sentence or like paragraph with some omissions. And by trying to like see like a lot of crawling and data on sentences, statement, dialogue that you've seen, that it's seen from across the world, across the internet, it's able to like see like there are some context around this because I've seen similar thing. I've seen similar thing before. For example, if I say I'm using like salt to do dash, and I remove like say if I have seasoning, for example, and I omit salt, it's going to see the probability of what is the most suitable words to be here. But because I understand like seasoning is there, it has crawled and seen so many of those contexts. That's how it learned to be able to like see, okay, the probability of having salt in this missing statement is higher than having a tree or like broccoli, right? Because it knows like I've seen salt in so many seasonings. So that's why it's able to like build that generalized representation. And because of that generalized representation, if you now have specific things within your organization that is saying, you know what, I think this sort of conversation we're seeing from maybe our client is slightly different. You don't need to like train from scratch because you have a model that has learned all different kind of conversation, all different kind of text, and will be able to quickly adapt and tune to your own sort of specific context. And it's like mile apart from, like I say, mile, maybe like billions of miles apart from just doing a search on Google for information, right? Because now it's more, we're getting like, closer to what we say, how, human actually like think. And I know those knowledge, we can say they're coming from what humans, have done and text they've written and pictures they've seen. But again, it's still like an evolution. So you're right, that generalization, I think is the biggest piece that we're missing when everybody like talks about things like ChatGPT, is that generalization that allows you to now work on enabling your organization or yourself or an enterprise with specific task implementation leveraging AI.
Yeah, incredible. It's just incredible. And I know since ChatGPT came out, I know we're not talking about that solely, but in November, it's the uptake on that has been remarkable. And
That's right.
And if you think we've moved that far in a month or month and a half, 2 months, like what's going to happen in the next few months? So it's really an explosion. Wonderful.
Yeah,
And
that's why. Yeah. Sorry.
I think that leads to my question, right? I mean, as an academic institution, we have to ask the experts, what do you think of ChatGPT and how it impacts us as universities?
But that's actually a really, really great question. And I know this has been like concerns, to many. I think there's a whole lot, of conversations that needs to happen around responsible AI use, right? And that's why, like at IBM, we're really great around AI ethics when it comes to like transparency around how the AI is making decision, how you're using it responsibly. But again, I've seen like people like comment that, okay, you give a task to students now, they can just go to ChatGPT and say, okay, write me a code skeleton for this, and it will write. So I think it's more like a collective responsibility as to how maybe with the university, and we can do like a whole lot of things without like government agencies. How are we going to ensure the responsible use? It's good to like open like students to all the knowledge they can have, because now we're saying beyond the classroom, you can learn like a whole lot, like without necessarily like having to like go to the library, like people or just go and Google. You have things that can relate to you. So it's is the ethic piece that I see as the challenge. Some see it as that positive piece of like expanding the classroom. The other piece is more, how do you really manage that? We can say, okay, in university, you can like really use it. I'll give an example when it comes to responsible AI. There was this um, particular story that was in the news where a university in the US used like AI model to determine students that will not be able to like finish. Like, okay, if we admit like certain students, they run the algorithm, given their profile, a lot of them would drop out. Like, what is the probability that they're going to complete? And based on that, they were biased about some of the students they gave admission to because they're assuming they're not going to finish. Now, another, university within the US was using exactly the same AI, but determining students that will not finish. But instead of denying them admission, what they're now doing is to say, how can they like adapt to like accommodate their specific need? Because what you now see is more, the bias there is based on maybe some specific demographics, some specific like economic classes. That's what like the explanation that will come back that the other university they actually like, think about. So I think the biggest piece that is going to really help us uh, as like as people, as institution, as organization, and as governments, like coming up with that framework for ethical AI use. That would be my perspective, but I know like different people can have a different view. But it's hard now. It's already gone beyond what we can say. Oh, you can't use this because everybody has like access to it.
And I think that touches, that's a really interesting response. It touches really nicely on what we did last week. So in our session last week, we talked about data governance. And one of the big issues was this idea of trust. And you kind of brought in this responsible AI. And I'm curious from a consulting perspective, obviously you guys are the experts at IBM. How do you establish trust with your clients on these products or on AI in general? How do you go about just creating with management that, this is a product that we're creating, it's based on unsupervised algorithms, but we think it'll work for your particular situation? Ashek had such great examples of AI in practice, but then how do you go that next step and sort of formalize and say, this is why, management should trust our expertise, if you will?
Right. Maybe I should first let Ashek talk about that. Again, you're talking about how we're engaging with a client. I think from me, we tend to like start from what drives the organization, right? They own a business, they run a business. What drives them? What's the agenda? What's the performance things they want to like really accomplish? And that's why I think like Ashek and Nizar will be able to like actually like speak like a lot more to that, because our whole agenda is enabling our clients to be successful in their agenda. But again, I'll probably like let Nizar and Ashek actually speak to that.
I just stepped back in. What was the question?
Oh, really? No.
So it was more, Nizar, the question of, one, you talked about ROI. So how do you rather as IBM convince management on the merits of, an algorithm or of artificial intelligence initiative? And how do you gain and establish that trust with your clients? And just touching, because last week we talked about data governance and how there was a big issue surrounding trust in these algorithms.
Well, I'll tell you different ways that we've done it in the past, and then I'll tell you about the most successful way that I've seen personally. So, helping them, convincing them of the ROI. We've done it where we come in, we create business cases, we spend time with them, we crunch the numbers, we show them the money, basically. We've also done it where they're kind of convinced already, and we convince them more that the technology can do what they need to do. But what I found to be most effective is just going in and helping the clients. So usually they have a business problem. Rarely do they have a true technology problem. They have a business problem, and that business problem is usually a human problem to begin with, which is leading to inefficient business processes, poor interactions with customers, sometimes catastrophic failure of assets. So we just dig into that and we offer our expertise, helping little by little, and eventually they trust us enough to open up and take a look at the hard hitting issues in their operations. And then where we've had a lot of success is in making small or incremental improvements to processes that scale massively. So I'll give you an example of one that's floating around a lot right now. Next best action in customer service. So the idea that you can generate the next best action that you should take to close a lead or resolve a customer's issue. A lot of this happens out of the box with technologies like Salesforce and other platforms. What we're looking at is, what if you could be 10% better, right? You have a 10% better chance that the next action that you take of the 6 or so that are on the docket that you're getting from your platform is the right action. It's so small, so incremental, but when you think of how many interactions that scales across, like hundreds of thousands of interactions, the dollar value starts to become bigger and bigger and bigger. And then when you consider the brand value that's associated with better customer service, suddenly you have intangibles too. And that helps justify investments in AI, which tend to be very, very costly. So you're looking really for business problems and human problems that you can solve with incremental improvements. And if you're lucky, you'll eventually work your way to the big problems that, if you solve, will completely transform an organization.
So I know you guys have to leave at 5 o'clock. So I just wanted to thank you for that answer. And I think it's really important, even for all of our students, to learn that, because when we sort of come into academics, we always want to hit the home run, but sometimes it's these little singles that, small incremental change can have profound impact. So I think that was a really, really important point, and I wanted to thank you for it and just express to our students that it's true. Sometimes the smallest change can really make big impacts within an organization. So thank you, Nazar.
Yeah, I'm just going to follow a quick question. Again, I'm mindful of the time, but Nazar, since you, Michael, you opened that question about trust, and Nazar, you had mentioned a big thing is about the culture and how to get the end users, not the data scientists, but how to get them to understand and embrace the AI. So yeah, that's hard. How do you do that? And trust is a piece of that, right? How do you get them to trust something they don't understand?
This is where I really defer to Omolade, but I'll say transparency is, from a business perspective, transparency is the key. Helping them understand how it was built, why it was built that way, why it's making the recommendations that they see, because AI can be wrong in very interesting ways, non-human ways that don't make sense to someone who's not privy to the context. But I'll let Omolade dive a bit deeper, because this is really
I'll maybe add one point on this, is that, like, what we've been talking about is that you need to understand AI is here to augment human, not to replace human, because at the end of the day, with all the great technologies we have out there and everything we made, AI is still basically an administrative assistant, right? It's not it's not a graduate student yet, right? It's not somebody that you can even give the new grad job, right? It's meant to be an intern, right, in training, right? If you kind of think about the student context. And so AI is just going to learn with some skills, right? Some data, some knowledge, and then we'll have to kind of use it, train it, provide it feedback, right, on the results, retrain it, and that's how it will get better, right? So it's something that requires continuous investment, but the main value is the ability to scale, right? Like the amount of data it can process and provide the analytics, it would take a lot of human. And so the first version of AI, we just need to really look at, if I were to do this, it would take me looking at 10 documents and collect 10 different things and write that one paragraph. AI is just going to be able to do that in a matter of minutes. And that's the type of being able to describe mass amount of data in a smaller context is kind of like what ChatGPT is doing, right? And that's basically how we have to think about AI. And then it will slowly grow and basically bring more value. But at this point, it's really cutting our own manual time and giving our manual task of collecting data and analyzing it and providing the insight is what AI is being used for from a business context.
Yeah. And that was actually, really, great one. I was going to go a different dimension, but I think Ashek put it in good perspective. And that's why when we approach like ethical AI from IBM perspective, we talk about three things: trust, transparency, and explainability. That explainability component is really key, because if you can explain why a model, a solution is advising on the sort of decision, then you can trust that solution, and you can have confidence because it's transparent and it's explainable. So that's really like key and foundational to that particular adoption of AI.
Okay.
And also one last piece, I think from the augmentation that Ashek mentioned, for us to always see the difference between AI being like decision support versus decision making. As of today, it's not totally to like make all of the decision, it's to like support the decision that we're making.
It's augmented
Right.
intelligence, right?
Right.
Yeah.
Right.
People think of it as artificial, but I agree. I totally agree with you. Well, this has
Thank you so
been
much.
fascinating. I think, Michael, you said that they have to leave at 5, but Ashek, did you want to have a closing comment there?
Well, just everybody, feel free to reach out. Each of us, Omoladi, Nizar, and I are available on LinkedIn. Sometimes we publish content there as well around this type of topic. So connect us with LinkedIn, and we are based across Canada, so we have locations. Like Omoladi is from Calgary, me and Nizar based out of Toronto. Our Montreal team is very strong in this space as well. And if you want to do something, even like, let's say UTM, want to do something in Toronto, right? We can get together. We have a new office in downtown, right beside Scotiabank Arena. If you want to come downtown, we can host you. We're just happy to collaborate further on this. If you have a use case, something you want to partner with, in terms of just tinkering, right? Like for us, I think it's about, we have our business, we have our projects, but there's a lot we can learn with each other by tinkering with different things, and always happy to kind of just get together and see what are the things that the students are thinking of as the use cases and what we can do together. And happy, I'm sure Nizar is kind of have that mandate right now to kind of build like a new startup mode for our AI opportunities, create some new ideas, and he'll be happy to probably host any discussion around that.
Thank you, Ashek.
I would say more than happy to have any sort of discussion. I love the dialogue. Fantastic questions, well thought out questions. You're asking similar questions to our C-suites, and our clients are asking us too. So yeah, just reach out anytime.
Well, thank you. I think we will take you up on that. I love the idea of having a little sandbox environment, and that's partly what the Big Data AI Hub is meant to be, and to increase these collaborations between academics and students, and practitioners and experts like yourselves. So this has been fascinating. I don't see any questions in the Q&A. And I'm mindful of the time. So I just want to say sincere thanks to the three of you. It's been an amazing conversation. And we appreciate you spending the time with us today. And I am going to call you up for sure. And I'm sure a few others will as well. But just have these conversations, because I think having these conversations with experts like yourselves really help us all move ourselves along a little bit. And I think, to your point, Nizar, that we need to move more people along a little bit, so that we can embrace it and trust it. With that, I think we'll bring this session to a close. Again, our thanks to the three of you. That was exceptional. And just want to say again that the recordings will be available on our website if you want to go watch later. And our next session is on Feb 9th, and we'll be talking about hybrid cloud. And I think IBM will be joining us as well for that session. So we hope to see you there. So thanks again, everyone.
Thank you so much for having us.
Have a good evening. Bye-bye.